Okay, so today is part 3 of our discussion of the Kelantan module, which is a pretty slow lah. Okay, these holidays have been kind of slow. Like the last holidays, I had a lot more, but I think it's okay lah. This time we can just take it as slow as we want, and we can see where that takes us lah. Okay, but I hope that in going through all these Kelantan questions, even though they're module questions, not really trial paper exam, but you kind of get the idea and the skills that you need, okay, behind answering this lah. Okay, of course, having the knowledge is important, but a huge part of what we're doing in this holiday program is more to do with answering techniques. Okay, to remind you all how to answer the questions, so that you don't have to think about it as much as you have to think about what is the content that you need to know. Okay, so that is the more important thing. Okay, so the last time we left off at question 17, okay, which is a section B question. So today we're going to go and finish up the rest of the questions until 24. Okay, and this is question 18 all the way to 24 lah. Okay, but question 18 is still a construct item number 9, okay, which is a section B question. Okay, so section B, remember you have 2 questions, 9 and 10, and you have to choose one lah. Okay, and we don't know whether there's satu soalan form 4, satu soalan form 5, atau dua soalan form 4, or both questions are for form 5. There's no guarantee for this. Okay, so not so important. The topic is not so important. The important thing is make sure that you are aware of, okay, section B, these are the kind of questions I need to be prepared to answer these questions. Okay. Diagram 18.1 shows an observer watching the image of pool water on the sand surface during a sunny day. Okay, so this guy is standing and it's a sunny day. Okay, ada matahari lah, and he sees this kelopak air di sini. Okay, he sees a pool of water over there, and it's like, oh, okay, what is this pool of water? Like, what do you do lah? Okay, so of course, this is what we call a mirage. Okay, dalam bahasa Melayu, mirage is logam maya. Okay, and it is important that we know which phenomena we're talking about. Okay, this is the phenomena of total internal reflection. So explain how the pool of water is formed. Okay, so you need to talk about so the important things lah. You need to talk about, of course, number 1, you need to talk about how the refraction happens, because essentially the pool of water is formed because it is actually an image of the cloud. Okay, so we see the pool of water because it's actually an image of the cloud. But how does that cloud appear pada permukaan bumi lah? Okay, so this is how we would answer this question. Okay, first of all, you need to remember that you need to talk about the layers of air. Okay, so the air on the sand okay, is hotter. Is hotter? Yeah, it's hotter. Okay, is hotter than the air in the clouds. Okay, so that's the first point. So here the air is hot. Okay, hot air. Here is cool air. Okay, and again, when we say hot air and cool air, it's a comparison. I'm not saying that wow, on top is very cold and at the bottom is very hot. It's just di bawah lebih panas daripada di atas. That's the more important thing. Okay, so that's the first point. Air on the sand is hotter than the air above the clouds. So because of that, okay, so because of that, hot air, okay, is more optically dense, okay, than cool air. Okay, so the light, so since this is hot air, okay, so the optical density is higher than this one. This one is low optical density. Okay, so when the light comes, okay, when the light comes from the cold air to the hot air, it's going from less dense to more dense. Okay, sorry, hold on. Yeah, less optically dense to more optically dense. Sorry, sorry, my mistake. Hot air is less optically dense. Okay. Cold air is more optically dense. Yeah, correct. Okay. Hot air is less optically dense and cold air is more optically dense. So when light travels from the clouds, it's going to travel from cool air to hot air. Okay. And it's going to travel from more dense to less dense. Okay. So the light travels from cold air to hot air and refracts. Okay, and refracts, and when you talk about refraction, you need to talk about whether it is refracting toward the normal or away from normal. And since this is more dense to less dense, okay, it will be away from normal. Okay, away from normal. So that will be our third point. Okay, and then as it refracts away from normal, the angle is going to get bigger and bigger and bigger and bigger. Okay, so when the angle of refraction, when the angle of incidence, okay, when the angle of incidence is greater than the critical angle, okay, total internal reflection occurs. Okay, and that's how we get the picture of the cloud lah. Okay, or we get the picture of the mirage. Okay, on this, because light is traveling from the cloud to the earth. We assume that. Okay, so cahaya berjalan daripada awan sampai ke bumi lah. Okay, atau sampai ke sand, because it's traveling from cool air to hot air. And as it travels, the more it travels, okay, it will reflect more and more away from normal. Okay, kalau setiap satu lapisan ini saya letak satu ini kan, satu garis, dia akan reflect away from normal sehingga berlakunya total internal reflection. Okay, and that's what we will see over here lah. Okay, so they refract and then after that we will yang kita nampak adalah total internal reflection. So itu yang sampai ke mata kita. Sorry, my drawing is very bad lah, but yeah, itu yang sebenarnya sampai ke mata kita. Fingerprint scanner, fingerprint scanner, then we are given, the scanner cannot identify the fingerprint very well, okay, because look at the prism. Okay, and then you are asked to suggest an optical fingerprint scanner which is able to produce a clear image. Okay, so you want to have a clear image now, because right now the image is not very clear because of different factors lah. Okay, so you are given all these options. You have K, L, M, N. You have different prisms, different intensities of light, focal length, and optical density. Okay, so as always, we analyze the table first, and then we make an informed decision. Okay, number one, angle of prism, 45, 90, 45, or 30, 90, 60. This is a very obvious one. Okay, it has to be 45, 90, 45. Okay, and the reason for this is so that total internal reflection can occur. Okay, I have no time to go into all the details, but if you remember, there are two types of prisms. One prism, okay, is all 90-degree prisms lah. Okay, it's either here is 45 and here is 45, or something like this lah. Okay, here is 30 and here is 60. Okay, now for total internal reflection to occur, you have to use the best one lah. Okay, the best one is to use 45, 90, 45. Okay, because if you use 30, 90, 60, there is a calculation to this which I don't want to go into because it's going to waste time. I would like you to just remember this lah. Okay, especially if this question comes up. Okay, when we talk about prism, we talk about 40, 90, 45, 90, 45, so that total internal reflection can occur. Secondly, intensity of light. Okay, do we want high intensity or low intensity? Basically, intensity is just the brightness of the light lah. Do you want it to be brighter or do you want it to be darker? This one is really a no-brainer. Of course, you want it to be high intensity. Okay, so that you can get a clearer or brighter image. Okay, this is no-brainer. Cannot. Okay, focal length of the lens. Okay. Remember, the focal length of the lens determines where your object needs to be. Okay. So if you think about this, you have the scanner, right? If you want the thing to scan, no, if you want the lens to be able to scan the light that comes, you want to make sure that the light doesn't have to travel so far in order to get to the, in order to get to the, in order to, get the light lah. Okay, so because of that, you will need a short. Okay, you will need a short focal length of the lens, because when you have a short focal length of the lens, okay, two possible things lah. Number one, the power of lens is higher, or secondly, if you don't want to use power of lens is high, you can get a bigger image. Okay, and that's what we want, because we want the fingerprint scanner to be able to scan the fingerprints. Kalau kamu guna kanta yang sangat nipis, then you have to put it so far away, you're not going to be able to get a clear image. Okay, or you're going to get the image so small, then it's like, apa gunanya kamu mau scan fingerprint bahkan kalau kecil betul topik ini. Okay, and on top of that, okay, if your focal length is very long, then this light sensitive microchip has to be put all the way behind here, no? So copier tube akan jadi sangat panjang. It's like a waste of space lah. Okay, so get a thicker lens, okay, kanta yang lebih tebal that has a short focal length. Okay, so that your power of the lens be higher, then you can get a bigger image. Okay, but finally, optical density of the prism. Optical density of the prism has to be low. Okay, has to be, sorry, low or high? Yeah, optical density prism has to be low. Hold on now. Optical density has to be low. Oh, sorry, my mistake. Optical density has to be high. Yeah, the obviously answer is L lah. Sorry, optical density has to be high because when your optical density is high, this is the formula. When your optical density is high, your critical angle is low. And when your critical angle is low, okay, it's easy for total internal reflection to occur. Okay, so you can give two possible answers lah. Okay, low critical angle or total internal reflection, okay, easily occurs. Okay, which is what we want. Okay, we want it so that it's easy to totally internally reflect. If the critical angle is so big, means you need to have such a big incident angle in order for total internal reflection to happen. You don't want, because it's a waste of space. Having a big angle means your light has to like, kau kena naikkan di sini, but then your fingerprint scanner akan jadi lebih besar. You don't want. Why do we want such a big fingerprint scanner? Bahkan, okay, use a small one with a small critical angle. Okay, but having a small critical angle means you need to have a high optical density. Okay, high optical density will give you a small critical angle, therefore the total internal reflection can easily occur. So it's all connected. Okay, if you don't remember much about whatever that's happening today, okay, try to remember this lah. Number one, the lens and the power of the lens and the focal length of the lens is all connected. Okay, especially for people who wear specs, you know this. When your lens is thick, okay, when your lens is thick, okay, your power of the lens is high. And whenever we talk about spec mata, oh, tebal loh kau punya spec mata, kan? Sebab kau punya kuasa adalah tinggi. And because of that, the focal length is short. Okay, the focal length is short because you want to see something from far away, maka kamu rabun jauh bahkan. Okay, oh sorry, kamu rabun dekat. Okay, your focal length is short, so that's why the lens is thick. Okay, so this is the number one connection. Number two, optical density. Optical density is higher, means the critical angle is lower, means total internal reflection easily occurs. I'm not saying that it won't occur if it is critical angle is high, but it's harder to occur. Okay, so total internal reflection will be easily occur. Okay, which is what we want. So when it easily occurs, then you can get a good reading, you can scan your fingerprint with no problem. There's no such thing as, oh, error. Okay, that's what we don't want lah, which is what is happening now. Okay, because possibly the total internal reflection is not happening very well. Ada masalah lah. Okay, it's not identifying the image very well, so you need to modify. Okay, and so we would use scanner L. Okay, and so on and so forth. So again, remember how the 8 plus 2, okay, remember this is an 8 plus 2 question. Please know how to get all the full 10 marks, especially if you already know how to answer. Sorry, if you already know the answer. Okay, because sometimes we find that people know the answer, but they don't know how to answer, which is the sad thing lah. You know, you already know the answer, jangan kurangkan markah sebab kamu tidak tahu teknik menjawab. Okay, diagram 18.3 shows the light ray that propagates from glass to water. Okay, so given, sorry, okay, so it's going from glass to water. Okay, so given the refractive index of glass is 1.66, refractive index of water is 1.33. So this is N is 1.66, this is N equals to 1.33. Okay, so the first question is, give one reason why the light ray propagating from air to glass is in a straight line. So this one, why is this in a straight line? Why doesn't it refract? Okay, so it doesn't refract because the incident angle, sorry, the incident angle is perpendicular. Okay, perpendicular to the surface of the glass. Okay, the incident angle is perpendicular to the surface of the glass. We assume like this. Let's say the surface I know is like this, okay, but the surface is kind of like in a straight line. So it's like 90 degrees. That's why it doesn't refract. Okay, so the normal line is the same as the, perpendicular to the surface of the glass. Question B, 2, find the angle of Y. Okay, so you have this angle over here and this angle over here with two different distance. Now this is a very rare formula, okay, but you use it when it involves two angles and two refractive index, okay, which is N1 sine theta 1 equals to N2 sine theta 2. Okay, N1 sine theta 1 equals to N2 sine theta 2. So let's say this is N1 and this is N2 to make things easier. Okay, so it'll be 1.66 sine 25, which is here. Okay, and equals to 1.33 sine theta 2. Okay, when you calculate, you get Y is about 31.8 degrees. Okay, 31.8 degrees. Then number 3, calculate the value of the critical angle for the glass. Okay, so we go back to the formula that I said just now, which is this one, N equals to 1 over sine C, okay, where C is the critical angle. And since we know, the refractive index of glass is 1.66, so 1.66 equals to 1 over sine C. Okay, so you pindah, and you should be able to get C equals to 37.04 degrees. Okay, just to show you what the working is like and how to get the answer. Obviously, since this is a 5-mark question, this will be 1, 2, 2. Okay, so if the answer is 1 mark, then you know that this working is 1 mark. Okay, and then this working is 1 mark. Pindah-pindah itu tiada markah lah. Okay, just substituting the values is where the mark is. Okay, all right. Let's go to question number 19. Shows a balloon-filled helium gas of volume 100 centimeter cube, okay, tied to a load of mass mkg. Okay, so there is a balloon with helium, okay, and it's tied to this mass lah. Now the balloon and the load is stationary and is floating in the air, and this is a very important thing. Okay, it is floating in the air, it is stationary, it's not even going up or going down. The density of the air outside the balloon is 1.20 kilogram per meter squared, per meter cube, and the density of the helium gas is 0.18. So now you're given two densities. One is the 0.18, which is the helium gas, and the other one is the density of the outside air, okay, which is 1.2. Mass of the balloon is negligible. Okay, boleh diabaikan sebab dia terlampau ringan. Okay. When we talk about stationary and floating in the air, anything that is floating, first of all, you need to be aware that this is Archimedes Principle. Okay, Archimedes Principle yang menyatakan pasal keapungan lah. Okay, floating and this one. So if something is stationary or floating in the air, okay, dia tidak bergerak ke atas atau ke bawah, dia terapung sahaja, it means that the weight, okay, is equals to the buoyant force. Okay, because anything with, well, you know, anything with this one, the weight must, the weight is downwards, buoyant force is upwards lah, because it is being, this one. Hold on, give me 1 minute. Okay, so the weight equals to the buoyant force because it is, you know, it's not going up and not going down. So that means the two forces, okay, up here is buoyant force, okay, because of the helium, and downstairs, I mean, going downwards is the weight lah. Okay, so first question and is usually a definition question. What is the meaning of density? Density is mass per unit volume. Okay, it is a standard definition, and I think density is a Form 1 science definition, maybe. Okay. Then secondly, mark and name all the forces that acted on the balloon. Okay, so you have to, since this is a copy question, okay, you have to draw the diagram. Okay, not so pachang lah. Okay, can keep it simple. But the two forces are, the upward force is the buoyant force. Okay, and then the downward force is the weight. Okay, or the gravitational force. You can say gravitational force, but you cannot say gravity. Okay, because the downward force is because of the load and of course the weight of the helium gas lah. Okay, there are two weights involved here. So that's the downward force, and I would rather you say weight rather than gravity. If you really want to say gravity, then you say gravitational force. Okay, that's an important distinction to make. Okay, first of all, calculate the mass of the helium gas in the balloon. Okay, now if you think about it, you are given the density of the helium gas is 0.18. Okay, the density is 0.18. Okay, this one, and you are also given the volume is 100 centimeters cube. Okay, but don't forget that you have to change the centimeter cube to meter cube. Okay, so it's divide by 100 3 times. Okay, so density formula is density equals to mass over volume. You are given the density, which is 0.18, equals to mass over the volume is 100 times 10 to the power of negative 6. Divide by 103 times. Okay, because the original one is 100 centimeter cube. You want to change to meter cube, so centimeter cube to meter cube is times 10 negative 6, or divide by 100 3 times. 3 times, because centimeter to meter is divided by 100. Okay, so when you do all the calculation, you will get the mass is about 1.8 times 10 to the negative 5 kilograms. Okay, that's what you're supposed to get lah. Now, then you will get the mass of the load. You will need to calculate the mass of the load because that's the one that you don't know. So let's consider the original equation. I said the weight is equals to the buoyant force. Okay, so the weight is because of two things. Okay, so it is the weight of helium plus the weight of the load equals to buoyant force is rho GV. Okay, rho GV, which is because of the helium. No. Yes, because of the helium. Sorry, the volume is correct because of the helium lah. Okay, because the isi padu of the udara that is being displaced, okay, is equal to the isi padu of the helium gas. Okay, correct. So the weight of the helium, since you have calculated the mass, okay, it will be 1.8 times 1.8 times 10 to the power of negative 5, okay, times 9.81. That's the weight of the helium. The weight of the load, we don't know. Okay, so I'm going to say the weight of the load is 9.81 times the mass of the load, because that's what we want to count. Equals to, okay, density. Now this is the tricky thing. We don't use the density of the helium gas, because if you remember Archimedes Principle, what is being displaced, apa yang sebenarnya disesarkan, okay, is actually the density of the air outside. Okay, so it's very important this. The helium is pushing, but apa yang ditolak, itulah ketumpatan yang kita mau. So if it is in the water, that's why we consider the water density. We don't consider the, let's say ball and water, bahkan. We don't consider the ball density. We consider the water density, because the buoyant force happens when you push the air aside. When you push the water aside, then buoyant force akan terhasil. So we want to know how much is the density and the volume of the water. Okay, so the density of, sorry, not the water, the air. The density of the air is 1.2. Okay, gravity is, of course, as always, 9.81. And the volume, okay, the volume of, of the air that is being displaced is the volume of the balloon, which is 100 centimeter cube. So you will get the same thing again, 100 times 10 to the power of negative 6. Okay, so I want to draw your attention to this. This 1.2 and this is 100 times 10 to the power of negative 6. Okay, the volume may be the same. Okay, but when you count buoyant force, the density, you must take into account what is being pushed aside. Okay, yang ditolak ke tepi adalah udara di sekeliling. That's why we use that density. But how much is being pushed aside is the same as the volume of the balloon itself. Okay, sebab kalau kau punya tangan begini besar, itulah berapa banyak air yang kamu boleh tolak. Okay, how big is your hand? That's the amount of this one lah. That's the amount of water that you can push aside lah. Kan? It makes sense. If your hand is so big, takkanlah you want to push all the water around the side. No, you can only push whatever that is touching the water. Okay, it's not like you got any kung fu or some kind of magic. You don't touch, wow, I can move. No, no such thing. Okay, physics is a very simple one. Whatever you touch is whatever you move. Same as this one. Okay, so you calculate, and you will get m equals to 1.015 times 10 to the power negative 4 kilogram. If my calculation is a mistake, please let me know. Okay, I'm just telling you from what I'm looking at the marking scheme. Okay, so m equals to 1.015 times 10 to the power of negative 4 kilograms. That will be the mass of the load. Now, of all the calculation questions, buoyant force is one of those quite tricky ones, okay, because there's a lot of overlapping formulas. Sorry, a lot of overlapping things. Like in this case, you see, and they give you two densities, and you're like, which density you're going to use? Okay, so that's a very important thing. You need to know. If you're calculating buoyant force, the density of the thing is being pushed out. Okay, very important. Okay, the string that ties the balloon is cut. Okay, you cut the balloon, you cut the string. Okay, this is very obvious lah. What happens to the balloon? The balloon will float away. Okay, so let me write it down here. Okay, the balloon, okay, continues to float up. Okay, because it's helium. Okay, of course I know it's because it's helium lah. But what is the difference between helium and normal air? Okay, it is because the density of helium is less than the density of air. Okay, the density of helium is less than the density of air. Okay, so the buoyant force increases, increases, okay, because of the less density, the weight has become less heavy. Okay, and then finally, because the buoyant force increases, okay, the buoyant force increases, sorry, and the the buoyant force increases and astaga, what is this? Melebihi, and is more, okay, is more than the weight of the balloon. Okay, the buoyant force increases, it becomes more than the weight of the balloon. That's the most important thing. Okay, when the weight of the balloon is less than the buoyant force, okay, so it's going to go up lah. Okay, that's the 4 points that you need. Sorry. Okay, you are required to choose a submarine that is able to be used for deep underwater exploration and at the same time able to move with high speed and lasting. Okay, sorry. Dalam bahasa Melayu is laju tinggi serta tahan lama. Okay, let's do that. So we want to choose the best submarine lah. Okay, so you're given QRST, which is over here. Okay, this is a pretty easy one, I think. Okay, let's start with the shape. The shape of the submarine should be aerodynamic. Okay, and not aerofoil. Aerofoil is Bernoulli's principle, but aerodynamic is to decrease water resistance. Okay, and this is something that I always emphasize. When you talk about aerodynamic, when you talk about aerodynamic shape or streamline shape, another one is called streamline. Although there's no choice here, but it's also good to know. Okay, streamline shape or aerodynamic shape, you need to be very clear about what is it that you are resisting against, what is it that you're fighting. So in the case of the submarine, kamu mau mengurangkan rintangan daripada air. Okay, obviously, because submarine, they travel underwater, but you don't have air underwater. I mean, you don't have, the resistance of air. So that's a very important thing. Okay, when you talk about resistance, as much as you can, mention the type of resistance that you are going against. Water resistance, air resistance, okay, frictional force. Okay, give specific names. Don't just say resistance only. Okay, because resistance is, can be some. Okay, aerodynamic shape is, okay, so streamline shapes that are streamlined is like this. Kalau kau pandang dari atas, okay, so like a boat is streamlined. Okay, it's always, saya pernah dengar ini, tajam di atas atau tajam di depan. Okay, yeah, the right word for it is streamline. Aerodynamic, aerodynamic is usually given to, like for example, racing cars. Racing cars are aerodynamic because it's low and it is low and dia punya shape macam ni kan. Sorry, okay, it's low so that the air doesn't really have so much resistance to go across it lah. Okay, so submarine also is kind of aerodynamic lah, I guess. Okay, like this lah. Okay, that kind of shape. Tapi ini adalah pandangan dari tepi. Okay, so this is the submarine. Okay, but this one is pandangan atas for a boat or anything that is in the land, in the sea. Okay, which is streamlined. Decrease angin resistance. Aerodynamic is usually correct. I know aerodynamic is usually, when we talk about aerodynamic, is decrease air resistance. But when we talk about submarine, we don't usually talk about air resistance because submarine is not meant to travel in the air. It's supposed to be travel in the water. Okay, why we cannot use aerofoil? Because aerofoil has to do with the shape of the wing. Kalau dilihat dari tepi, okay, the shape of the wing, and it is supposed to produce a lift force. Okay, this is different. Okay, so ini adalah want to go forward. Aerofoil is want to go up. Okay, so it's a different purpose altogether lah. Size of the ballast tank. Okay, the size of the ballast tank should be big. Okay, and this one, because when you have a big ballast tank, okay, you will have a bigger buoyant force. Okay, and that's important lah. A lot of people, and this one saya pernah dengar lah. A lot of people tend to choose the smaller ballast tank. Smaller ballast tank, and then they give the reason so that it's lighter. But the submarine is already so heavy. and it's supposed to be heavy because you want to go into deep water. Why would you want a light submarine? So that it's easy to carry. Wow, as if you're the one that's carrying it. No, think about the bigger purpose. Submarine has to go as deep as it can go. Okay, because of spy operation or whatever lah. Okay, so if you want it to go deep, you need to give it a lot more weight. And you need to give it a lot more weight. So it is able to go much lower. So you need to have a size, you need to have a much bigger tank so that it can go deeper into the ocean. Okay, so we can't really say, oh, it's light, so it's easier to carry. Okay, no, we can't do that because it's not a handbag. Okay, it's a submarine, it's not a handbag. So we don't really talk about easier to carry or light lah. Okay, low rate of rusting. This one is a normal one. Okay, kadar pengaratan mesti rendah so that it doesn't spoil easily, dia tahan lama, all this lah. Okay, does not rust easily, or the other one is long lasting. These are the two pretty standard answers lah. Okay, it doesn't rust easily, it is long lasting, and so this one. Okay, type of power source. Either you use nuclear power source or kerosene, which is natural gas lah, or petroleum. Of course, we use nuclear power. Okay, because nuclear power is more effective, is cheaper, it lasts longer. Okay, so higher efficiency. Okay, lasts longer. Okay, you don't need to keep refilling because a little bit of a little bit of radioactive material can power for a long time and a lot. So that's what we want lah, so that you can stay down. Otherwise, every time you finish your fuel, you have to go up and then refuel and then come down again. What a waste of time that will be lah. Okay, so in this case, S will be the best submarine. Okay. For this. Sorry, I just want to mention one thing. I think maybe okay. I just want to mention this. Size of the ballast tank. Actually, when I think about it, yes, it provides a bigger buoyant force. But I also think that when you have a big ballast tank, okay, increase the weight of the submarine is also a good answer. Because you want it to go deeper. Yeah, I know. When you increase the weight, you get a bigger buoyant force. That was normal. Okay, but you can also, if you want to say increase the weight of the submarine, so that it's able to go down deeper. That's also important. The bigger buoyant force happens is bila kamu lepaskan, bahkan when you displace the water, then you get, because there's a lot more water, so it is able to go up much faster. That's why I say bigger buoyant force is also can. Okay, also can. But this answer also I will probably accept. Okay, to increase the weight of the submarine. It's a good answer. Okay. All right. Let's go to question 20. Now, this question 20 is the one that I mentioned in the last class. Dia bergabung dengan this question. Okay, so this is the one. Okay, there's a missing component, but we'll get to it when we get to there. Okay, transistor circuit. Okay, transistor, remember, is a main function of the transistor. Okay, is as an automatic switch. Okay, this is a standard answer. Automatic switch. Okay, or current amplifier. These are the two functions of the transistor. Very standard. Okay, switch automatic atau amplifier arus. Okay, state the readings on the microammeter and the milliammeter. Sorry, micro is here, milli is here. Okay, this one, sorry, micro is here, milli is here. Okay, when S1 is lit up and S2 dimatikan. Okay, so S1 dia disambung, ini tiada. Okay, what will happen is microammeter ada lah. This one is very normal lah. Okay, microammeter ada. Okay, milliammeter tiada. Okay, so I'm just going to write microammeter got reading, milliammeter no reading. Okay, so I know that this question is a little bit confusing because the question is asking state the readings, bahkan. And then I have had somebody ask me, what is the reading? I cannot see any reading. Actually, it's just state whether there is a reading or no reading lah. Okay, now S1 dimatikan, tetapi S2 dihidupkan. Okay, so you have S1, sorry. Okay, you have S1 dimatikan by S2 yang kau kasih hidup. Like this. Okay. Now, if we follow the logic of B1, it should be millimeter got reading and micrometer got no reading, right? Kan? Sebab ini adalah kononnya lengkap lah. Kan? Sebab the switch is on. But we need to remember this, that the transistor can only work if the base current is flowing. So here is the base current. Okay, this is the collector current. So transistor very important, no? Collector current, even though the collector current is on in that sense, but because the transistor is not working, because there's no base current. No base current means no collector current. Okay, that's why it's called an automatic switch. It is automatic if there is a base current. Then your collector current ada. Okay, so micrometer, millimeter, dua-dua tiada bacaan. Berhingus sudah saya. Okay, dua-dua tiada bacaan. Okay, so write down there to remind yourself. Okay, base current affects collector current. Dan bukan terbalik. Okay, collector current dia tidak mempengaruhi pun base current. Base current is like whatever lah. Okay, you tak mau hidup, not my problem. Yang penting saya hidup. Tapi collector current dia sangat bergantung kepada base current. Okay, if there's no base current, the collector current is like, oh sorry, I can't live without you, base current. Wow. Okay, so please remember that. All right. Now, based on your answer in 20A, which is this, okay, explain how the circuit functions when the rheostat is adjusted and both switches are switched on. So this is a very standard, this one lah. Okay, so let's assume that we're talking about both the amplifier and also the automatic switch. Okay, so the first thing will be base current. Sorry, when base current flows, okay, collector current will flow. Okay, secondly, a small change in base current produces a big change in collector current. Okay, 2 points. Sorry for my horrendous handwriting. Sorry. Okay, so ini 2, ini 1. Okay. Bila ada base current, ada collector current, automatic switch. Perubahan kecil pada base current akan menyebabkan satu perubahan besar pada collector current. That is amplifier. Okay, so kedua-dua lah. Saya jawab untuk kamu. Okay, reading of the micrometer is 50 microamps. I'm going to put it here. Okay, and the reading of the milliamp is 5.3 milliamps. Okay, when both switches are turned on. So calculate the current amplification. Okay, current amplification, beta, I don't know why it's called beta, is IC over IB. Okay, this is very standard lah. Okay, so IC over IB will be 5.3 times 10 to the power of -3 over 50 times 10 to the power -6. Remember to change it to milli and micro lah. Okay, and remember it is amplification. So the bigger one has to be on top. 5.3 times 10 to the power -3 is bigger lah. Okay, the smaller one is at the bottom. So you get about 106. Okay, about lah the answer. Okay, the emitter current, this is another formula. Emitter current is the same as base current plus the collector current. So kau kasih tambah saja and you will get the answer 5.3 times 10 to the power of -3. About lah. Okay, 5.35. Okay, let me make it a bit smaller. 5.35 times 10 to the power of -3. Very, very, very not so much difference compared to the collector current, which is very big already. Okay, but just to recap lah, these are the formulas. that are involved when you're talking about transistor, which is only two, the amplification and the emitter current formula, which is IE equals to IB plus IC. Okay, now we come to the choice question. Okay, making the choice. So diagram shows an incomplete electronic circuit of a temperature control system. Temperature control, okay, so kita mau suhu yang mengawal. The circuit will automatically switch on when the room's temperature is high. Okay, isn't that nice? When it is very hot, like it is now, okay, then aircon will turn on immediately. Kan bagus kalau begitu. Okay, table 20 shows 4 sets of electric components that may be used to complete the circuit. Yada yada yada. I'm sure we will have to make a choice lah. Okay, so if we take a look at the question, it says study each type of the electric components, choose the most suitable, and choose the most suitable set and give them the reason. Okay, so we do as we have always done. So in PQ, there is a light-dependent resistor and a thermistor. Okay, this one is a no-brainer. Okay, because the question says it is a temperature control. Okay, temperature control means kita mau thermistor. Okay, sebab temperature, thermistor. Okay, dia adalah perintang peka haba. LDR is a light-dependent resistor. Dia adalah peka suhu, peka cahaya. Okay, so we don't want it to turn on. We don't want it to turn off when there's no light. We don't want. Tidak ada kaitan dengan cahaya lah. Okay, it is more to do with heat. Okay, so we say thermistor. Okay, then we can say, okay, it is sensitive to heat. Okay, or if you remember how a thermistor works, okay, the resistance decreases when the temperature increases. Okay, that's the one lah. Because if you remember, if let's say this is the thermistor, okay, resistance here is low. When the temperature is high, resistance here is low, so resistance here is high. Resistance is high, base current will flow. Base current flow, collector current will flow, and therefore the aircon will be switched on. That was very normal. Okay, so we use thermistor. Okay, RS. RS is here. Here, usually, you have two choices lah. You have a capacitor and a resistor. If you remember the transistor circuit, we never work with capacitor. Capacitor is only for diode. Okay, so this one obviously will be a resistor. Okay, so what is the purpose of the resistor? Is to control the base current. Okay, that will be what the thermistor is for lah. Sorry, what the resistor is for. Okay, WX. WX is over here. Okay, you have two choices, either a diode or a coil. Okay, so this one will obviously be a coil lah. Okay, so this is what we want. We want a coil. Okay, so that you can either increase the voltage, okay, or you can complete the relay circuit. Okay, when you have a coil here, okay, you have a coil here, then it's connected to a relay circuit lah. Okay, which let's not talk about this now lah. Okay, but the relay circuit is there. Okay, finally, TU, the cell. Should it be cell 1 or cell 2? Now, if at this stage, if you look at it, you kind of know where this is going already lah. Okay, it's very obvious lah, if not obvious by now, okay, that it should be cell 2 lah. Okay, so even if you don't know, when you take a look at the analysis, you're like, oh yeah lah, I think it's probably L. Let's just go ahead with L. Okay, so you go with cell 2. So why cell 2? Okay, because when you put here, okay, when you put the positive terminal here and the negative terminal here, okay, it is forward bias. Forward bias to the transistor. Okay, that's what I want. Because the negative terminal is touching the N. This is a NPN. So the positive terminal is touching the P side. Okay, so that's why it is forward biased. Okay, so the best of it will be L. Okay, all right. Let's go to question 21. I don't know why they say this is construct number 10 now, but it's pretty much the same thing anyway. But let's just go ahead with it lah. Okay, diagram 21 shows a fighter jet of mass 9,200 kilograms. Okay, so there is a mass of or weight, okay, of 9,200 kilograms. Okay, that is going at a target at an angle of 35 degrees. Okay, so the magnitude of the engine thrust is 2.5 times 10 to the power of 5, and the drag is 2.0 times 10 to the power of 4. Okay, the resultant force that is perpendicular with the engine thrust is 0. Okay, that is the question lah, which they have to give in this. Okay, so first of all, what is meant by drag? Apakah yang dimaksudkan dengan seretan? Okay, it is an it is a force that opposes the motion of an object. Okay, satu daya yang menentang arah gerakan objek. Same like frictional force, okay, it's also a force that opposes the motion of an object. Okay. All right. Then only you come to this question. Okay, calculate the component weight of the fighter jet that is parallel with the engine thrust. Okay, so let's take a look at this. In order for us to answer this, okay, we need to imagine that this plane over here, okay, this plane over here is flat. Okay, it makes it easier for us to see that. So let's say this is the plane. Okay, and this is where it is. Okay, so the thrust is this way, 2.5 times 10 to the power of 5. The drag is this way, 2 times 10 to the power of 4. Okay, but the weight is this way, 9200 kg. Okay, and you know that any Sailboat force, because this is the permukaan bar, okay, any Sailboat force has to be resolved into two components. I'm going to call this W. So this will be W. This will be, I'm going to put here theta. Okay, W cos theta, and this is W sine theta. Okay, so the question is asking, is the component weight of the fighter jet that is parallel with the engine thrust, which is this one, W cos theta. Okay, now question what is theta? Okay, of course we have to know what is theta lah. Sorry. Okay, so if this is 35 degrees, okay, if this is 35 degrees over here, okay, this angle is not 35 degrees. Okay, be very careful, people. Okay, this angle is 35 degrees. So this angle will be 55 degrees. Okay, so the theta that we want is 55 degrees. So, and the W obviously is M times G lah. Okay, so the component weight okay, is the component weight, I'm going to call it WX lah. Okay, for this one. This is WX. Okay, so WX equals to W cos 55. Okay, and W will be 9. Sorry, how much is this one? 9200. Okay, 9200 times 9.81, the weight. Okay, of this one times cos 55. Okay, which will give you 51766.42. 51766.42 newtons. Okay, so that is the reason. Okay, so it helps us to see when we make the Sailboat itu bahkan kita kasih jadi straight. then you see that actually the 9,200, that is the one that is actually the sailboat force. The weight is actually the sailboat force. Okay, kita kasih jadi the engine and the seretan or the drag. We make it as the flat one lah. Okay, not the sailboat one. So that we only need to resolve one particular force. Okay, the resultant force will be this one plus this one minus this one. Okay, 2.5 times 10 to the power of 5. Okay, 2.5 times 10 to the power of 5 plus 517,456, 517. Somebody has to verify this. Is it 56 or 66? 56.42. Okay, minus with 2 times 10 to the power of 4. You should be able to get 281,766.42. Sorry, 66. Okay, 51766.42 Newton. So the resultant force, okay, the forward minus the back, you get 281,766.42. Then you can use Newton's second law. F equals to ma. The F is 281,766.42 equals to 9,200, and you can find the acceleration of the acceleration of the fighter jet. Okay, which will give you about 30.63 meters per second squared. Okay. Okay. If the fighter jet continues to move at a smaller angle, okay, what happens to the acceleration of the fighter jet? Okay, so this one, same thing lah. It's a 4-mark question. Think about it. If you decrease the angle, okay, what happens? Now, the best way to look at this is we decrease this value. We decrease the value of this one and look at what happens to this one. Is it smaller or bigger than 51766? Okay, so let's say cos, instead of 55, let's say I use cos 40, smaller angle. Okay, cos 55 is 0.5735. Okay, cos 40, if I use a smaller angle. Oh, sorry. It's not the 55 that becomes smaller. It is the 35 that becomes smaller. If the 35 becomes smaller, then the 55 becomes bigger. So it will be cos, let's say 70 lah. Oh no. Okay, cos, let's say I use cos 70. Cos 70, you'll get a much bigger value. Oh, small value. Cos 55, sorry. Cos 55 is 0.57. Cos 70, you get 0.3. So you get a smaller value. Okay. If the value of cos becomes small, then this value will become smaller. And if this value becomes smaller, this value becomes smaller, and this one will also become smaller. Everything becomes smaller. Okay, so number one, the acceleration decreases. Okay, the acceleration decreases because the resultant force. Okay, the resultant force decreases. Okay, you can say that, okay, the value of the weight, the value of the weight, the component weight. Okay, the value of the component weight decreases. Yeah. Okay, the value of the component weight decreases, which is this. When this decreases, then the the total force to the forward decreases, and so your resultant force also will decrease. Why is it 4 marks? It seems like a very simple explanation. I'm looking at this marking scheme and it's repeating the answer. The acceleration decreases, the resultant force decreases. The smaller the resultant force, the smaller the acceleration. Wow. And then the last one is the force is is inversely proportional to the acceleration. It's the same point and they're repeating it so that they can get 4 marks. Huh. Very interesting. No, I will just maintain in this. Acceleration decrease, therefore the resultant force will decrease. That is in accordance with sorry, the acceleration decreases because the resultant force has decreased. Okay, this is in line with Newton's second law. Okay, semakin kecil the resultant force, semakin kecil the acceleration. Why would it be this one? So strange. Okay, the manager of a carnival wishes to install an advertisement balloon filled with gas at the carnival site. Okay, you are a carnival supervisor, and you're asked to suggest a suitable method to install the balloon so that it is safe and not affected by crosswinds. So you see this one. Okay, so you have a balloon. Oh, it's a big balloon. Okay, and you have a balloon iklan. Okay, right. You have a balloon and you want to, put it up so that people can see. Okay, so you have these 4 criteria: number of rope, maximum tension, size of the balloon, and of course the gas in the balloon. Of all the 4, the easiest and the most logical one is the gas of the balloon. Okay, so no need to think one. Gas of the balloon has to be helium. Okay, and why is the gas in the balloon? Why does it have to be helium? Because it doesn't burn easily. Okay, dia tidak mudah terbakar. Hydrogen is very, very easy to, to explode, so we don't want that. Okay, the size of the balloon, this is quite normal. Size of the balloon has to be big in order to get a bigger buoyant force. Okay, again, another buoyant force question. Okay, maximum tension of the rope. Okay, now when I was doing this question, I was thinking, why would they ask this? Is such a strange question, because the problem with the tension of the rope is that it has to be just nice. If the tension of the rope is too tense, then you will risk the rope breaking. But if the tension of the rope is not tense enough, okay, then you'll get the tali yang kendur lah, which nobody likes. Because tali yang kendur means the balloon can, go here, it doesn't stay very still lah. Okay, so you're thinking, is 1,000 too much? Is 2,000 too much? Is 1,000 too little? Is 2,000 too much? Okay, but when you take everything into consideration, you kind of want the maximum tension of the rope to be as maximum as possible. So we would choose a high value. Okay, the maximum tension of the rope should be high. Okay, then you can say not break easily. Okay, tidak mudah putus. Okay, or another one, can withstand. Okay, higher mass. Dia boleh tahan lah dengan jisim yang berat. Sorry, jisim yang besar. Okay, not break easily. You can also say can withstand strong winds. Okay, sebab kamu itu balon terapung makan, so it's going to be very windy and everything. So you want to withstand the winds. That's why you have this high tension lah. Okay, so that it doesn't fly here and fly there. Kalau dia kendur makan, it will just go all over the place, which is not very good lah. Okay, the number of ropes. Okay, obviously this is very logical. Number of ropes has to be high. High number of ropes. Okay, so that it is more stable, it is stronger. Okay, so there are many points lah. Okay, more stable, stronger. What else? Not break easily. You can say about pretty much the same things. Okay, not break easily. Okay, and at this, once you're done, you're done with Y lah. Okay, you will get the answer Y. Okay. All right. Somebody asked me, how do I get the last 2 answers? Okay, so if you're going to do it in the table form, okay, do it in the table form, so you get, okay, so this is 1, this is 2, this is 3, this is 4. Okay, so macam ni. Okay, so one is the number of ropes is high, and then you give the reason, not break easily. And then the second one is maximum tension of rope is high, not break easily. Okay, and so on and so forth. Okay, how do you get the last 2 marks? I will usually write is the most suitable, because most of the time the soalan akan tanya yang most suitable lah. Choose the most suitable. Okay, the most suitable method is Y. So the most suitable is Y. Okay, and then on the right side, you write the reasons. Okay, when you write the reasons, you only write these 4. Okay, which is maximum number of ropes is high, comma. What is the second one? Maximum tension on the ropes. Sorry, number of ropes is high. Maximum tension is high, comma. Then the third one is the size of the balloon is big. Size of balloon is big, comma. The last one is the gas in the balloon is helium. Gas in the balloon is helium. Tulis keempat-empat and then only you will get that final mark. Okay? I cannot stress this enough because there are a lot of lazy people in this world. They just say, oh, because Y fulfills all the criteria in the table above. No, tiada mark di sana. Kalau saya pun saya tidak akan bagi. Okay, because if you're too lazy to write the answer, then I'm too lazy to give you the mark. It's very, very logical. Okay, kamu malas menulis jawapan, saya malas memberi markah. You're not, there is no, apa, yalah, you're not, and there's no entitlement here lah, you know. Wow, I'm entitled because I'm smart. No such thing. You're lazy, you don't get the mark. It's very, very logical. So don't be lazy. Okay, because I feel that it's such a waste that because kamu malas, terus kau kehilangan satu markah. Okay, don't be like that lah. All right, last 3 questions. I think we should finish this. I don't want to delay this, so let's finish the last 3 questions. But we're going to this section C. Okay, and section C is question number 11, which is a compulsory question. Okay, compulsory means you have to know what to expect. Okay, number 1, of course, it will be a definition question, explanation question, very normal. Okay, then the third one, or one of the other questions, is the compare and relate question. Lepas kamu compare, then after that you write the relationship. The bigger the this, the bigger the that. Okay, and then finally, the modification question. Okay, you're required to modify or create something, okay, based on the properties that is given. So that is the 10-mark question. Also to answer in table form. That's important. Okay, all right. Let's see how far we can go with this. I hope we can answer everything today, because I don't really want to do another class all again. Okay, name the shape of the aeroplane's wing. This is a very standard answer. This is aerofoil. Okay, so explain how the aeroplane can lift up from the track when it moves at high speed during takeoff. This is a very standard. First, talk about the speed. Okay, the speed of air above the wing, okay, is greater than below the wing. Okay, secondly, based on Bernoulli's principle, the higher the speed, the lower the pressure. So the pressure of air above, okay, above the wing is smaller. Then below the wing, hold on. Okay, number 3, difference in pressure. So above the wing, okay, here is low pressure, here is high pressure. So the difference in pressure causes the lift force. Okay, difference in pressures Okay, the difference in pressures causes a lift force. So the force will go from the high pressure to the low pressure region. Okay, that's how you get the 3 marks. All right. 22.2 and 22.3. So 2 ski jumpers. Okay, that are this one. Of the same mass, ski down from a high platform. Same takeoff velocity, but a different attack angle. Okay, so take a look at the size of the angle, everybody. Take a look at the distance. Okay, comparing questions, as I mentioned again and again, is one of those questions where the only thing you need is a pair of eyes. Okay, when you can see it, okay, then all you need to do is just to be able to observe it and write down your observations. Okay, first of all, compare the magnitude of the attack angle, the landing distance, 1, 2, and the maximum height. Okay, let's take a look at this. Very obvious. This one, attack angle 1 is bigger than attack angle 2. Okay, look at this angle, look at this angle. Very obvious. Okay, you cannot see this one. Okay, number 2, look at the distance. Okay, the landing distance, S. S2 is bigger than S1. Okay, number 3, H2 is bigger than H1. Okay, compare, very, very easy. But remember to write your answers in full sentence. Okay, I'm just giving you the short version of the answers. In the exam, make sure you write a full sentence. Okay, now, hence relate the attack angle. Now you know that after comparing, then you have to relate. Okay, so relate the attack angle with the landing distance and the maximum height to make a conclusion regarding the relationship between the force and the landing distance. What, 3 relations? So strange. Okay, well, I don't think it's 3 relations, it's 2 relations only, but you have to kind of bring both together. So the bigger the angle, the smaller the landing distance and the height. Okay, as proven by this. The bigger the angle, the smaller the landing distance and the height. Okay, therefore, the lift force and the landing distance. So if you think about it, the lift force, which has a bigger lift force? Obviously, this one lah. Okay, because the height is higher. Okay, so the bigger the lift force, okay, the bigger the landing distance. Okay, so how do you get a bigger lift force? Is by having a smaller attack angle. Okay, smaller angle for attack. And this is something that we studied when we did Bernoulli's principle. Okay, it's not just about it is not just about producing the lift force, but you need to make sure that the aeroplane is angled at such a way that it produces an even bigger lift force. Okay, so there are 2 things at play when we're talking about aeroplane. Number 1 is Bernoulli's principle. Okay, secondly is the concept of the attack angle. Okay, you have to get the correct attack angle in order to get the maximum lift that you can. So there are 2 sources of lift force. One is from the attack angle, and secondly is from Bernoulli's principle. Okay, goodness, how am I going to edit this video? Okay, name the principle that is involved. Is Bernoulli's principle. Bernoulli's principle. Okay, just to remind you that Bernoulli is one of those names that people always get wrong. Okay, kurang 1 L, terlupa 1 R. Okay, I always see this every year and every time, so please be careful with this. Okay, Bernoulli, Archimedes, all these people's names, don't get it wrong. Because when you get people's names wrong, you also don't get the mark. Okay, okay, sailboat. So how do you modify the sailboat so that it can move at a higher speed and it is safe? Okay, using your knowledge of motion, force, and properties of materials, state state and explain the modifications based on the characteristics of the boat, of the board and the sail. So you need to talk about the board, you need to talk about the sail. Okay, so there are quite a number lah. Let me see. Yeah, there are quite a number. Okay, number one, the surface, okay, has to be smooth. So smooth surface is number one. Okay, because when you have a smooth board surface, then you will reduce water friction or resistance lah. Okay, because air resistance lah. Yeah, water resistance lah, water resistance. Okay, you have a smooth surface, you have this one, and then this, the one thing that I mentioned just now, remember, streamline. Okay, the shape of the boat or the board must be streamlined, like a surfboard like that lah. Okay, streamline. Okay, also the same reason, to reduce the water resistance. Thirdly, generally both the sail and the board can also be low density. Okay, and when we say low density, it's always the same lah, so that it is lighter, easier to carry. In this case, we want to be easier to carry, not like submarine. Submarine not so good lah. Okay, another one is sorry. Okay, the sail. Let's talk about the sail. The sail has to be big in size lah. This one is very standard. Okay, because if you want to travel very far, okay, you want the wind to push the this one very far, right? You need to have a big sail. If you have a small sail, how do you expect to travel very fast? Okay, so you have a big sail so that it can produce a greater, produce a greater force forward. Okay, produce a greater force forward. Besides that, you can also talk, and this one now, I really, for the life of me, I cannot really remember it now. The material of the sail is also very important because you don't want it to be made of paper, because paper will koyak lah kan. Kita mau mengelakkannya daripada koyak. But I cannot remember what is the material for sail. Okay, over here it doesn't really tell me as well. Please look it up lah. Okay, I can't really remember what. I guess you can use canvas lah, but there's a name for canvas one. Okay, there's a name for the material of the sail. Okay, but the reason why we use that material is so that it does not tear easily. Okay, it does not tear easily, but I'm so sorry, I don't remember what is the name of the material of the sail. Okay, if anybody knows, maybe you can type it in the chat. One other thing that you can talk about, since you're talking about tearing easily, you also have to talk about hard material. The material of the the board, okay, should be hard or strong material. Okay, so that it does not break easily. Does not break easily. Okay, so important these 2 points are quite important. We want to have a low density material so that it's light, but we also want it to be keras so that it doesn't break easily. Okay, and that's very important. Okay, and so we find that actually sometimes question 11 is not as difficult as it seems lah. Okay, some things are very standard one. Okay, low, if you talk about material, and if it is not a submarine, then we say, oh, low density material so that it is lighter, it's easier to carry. Hard or strong material so that it doesn't break easily. Okay, hard or strong material so that it doesn't tear easily. Okay, certain things, of course, have to do with physics. For example, streamline or smooth surface. Okay, everything is to reduce resistance or water friction. Those are more physics related lah. But some answers kan dia sebenarnya agak standard. Okay, tinggal kamu hafal, dan if you can apply into the situation, go ahead and apply it. Okay. Can you give more than 5 answers? Yes, you can. Okay. And will they mark you wrong? Okay. If let's say kau beri 6 jawapan bahkan, tapi 5 saja yang betul, and 1 adalah salah. Okay. Then you can still get the full 10 marks. Okay. You can still get the full. If you give, let's say, all, ada yang salah, ada yang betul bahkan, okay, you can still get the full 10 marks. Okay. So don't limit yourself to only 5, but always think of, try to get as many answers as out as you can that you remember. Okay. And since we're getting nearer and nearer to the exam, how do you help yourself to remember is by answering more and more questions. Because the more and more questions you do, the more and more you will find that, alamak, the answer is actually very standard. Begitu-begitu saja dia punya jawapan. Okay, dia tidak akan banyak berubah. Okay, it's quite standard. All right, 23. What is meant by 6 volts and 12 watts? Okay, they did not ask what is, so you have to explain it lah. Okay, when the voltage is provided. When the voltage provided is 6 volts. Sorry, it shouldn't be voltage, right? It should be potential difference. But okay, when the voltage provided is 6 volts, okay, 12 joules of energy is produced, okay, in 1 second. Okay, so the numbers will change, but the words don't lah. When the voltage provided is yada yada joules of energy is produced in 1 second, always 1 second, because it's power. Okay, power is energy over time. Okay, this second one it's a bit strange. They ask you to compare the type of the circuit. So when you compare the type of the circuit, this is very obvious lah. This is series circuit, and this is parallel circuit. So this kind of comparison is not this is bigger than this lah. You just have to say that 23.1 is a series circuit, 23.2 is a parallel circuit. Okay. So 23.1 is parallel, sorry, 23.1 is series, 23.2 is parallel. Compare the brightness in terms of the brightness of the bulbs. 3 bling bling, and this one is 6 bling bling. So obviously 23.2 is brighter than 23.1. Okay, the current that flows, take a look at the ammeter. Okay, obviously 23.2 is also bigger than 23.1. Again, reminding you that in answering a compare question, there is not really much. The skill that is needed is not your memory. The skill that is needed is whether your eyes are functioning well. Okay, because only a blind person cannot see that 23.1 has a smaller reading than 23.2. Okay, so be aware of this. Not every question in the physics exam is about knowledge. It's also testing your observation skills. Okay, make sure you know how to observe. State the relationship between the type of circuit with the brightness of the bulb. Okay, so again, because this is a compare the type of circuit now, you cannot really say the bigger the type of circuit. It's not. Okay, so you can say that the series circuit, brightness, okay. So brightness, in terms of brightness, series circuit produces less bright light bulbs, or parallel circuit produces brighter light bulbs. Okay, either way lah. Okay, so series less bright. Okay, parallel brighter. Okay, brighter light bulbs. To make a conclusion regarding the relationship between effective resistance and the current flow. Okay, now this one requires a little bit of knowledge. Okay, why is it that the current is bigger? The current is bigger because the effective resistance is smaller. Okay, so the smaller the effective resistance, the bigger the current flow. Okay, that's the relationship we want. Smaller resistance means more current can flow. More current can flow means your light bulb will be brighter. No? Okay. More current can flow means your light bulb will be brighter. Okay. This is a filament lamp. I think this is a question from last year. It's very familiar. Either that or one of the trial questions last year. I remember looking at these questions. So explain why the filament in a coiled shape produces more light. Why is it coiled? Okay, so we have to remember Ohm's law for this. Okay, so the filament in the coil shape produces more light because the length to increase okay, to increase the length of wire. That's number one. When you increase the length of the wire, the resistance increases. Okay, when the resistance increases, more energy, okay, is produced. And number four, the energy or the heat energy, heat energy is produced. And when there's more heat energy, there is more light is produced. That's it. Okay, you can, well, I guess you can say the heat energy changes to light energy. Okay, because if there's more heat energy, there will be more light energy because the heat energy will change to light. Now, I have this saying which I always use that I hope can become helpful for you. Remember that resistance produces heat. Always very important. There is a relationship between resistance and heat. When you rub your hands together, you're providing resistance and there's always heat there. Okay, so resistance always causes heat to happen. And when it is hot enough, it will turn into light. Okay, that one anybody can know. Okay, but the source of the heat is actually because of the resistance. So if you want to have more heat, you need to have more resistance. How do you have more resistance? Use a longer wire. Okay, that's why the filament bulb is actually coiled. We don't see, we look at it, it looks like it's just one line, right? No. If you look at it deeper into under a magnifying glass, you see actually it's coiled. Okay, so it's really genius okay, how they came up with it. They managed to put small coils in a wire. Okay. All right. Heating element in an electric kettle. Okay, this is definitely a familiar question. It's familiar because I probably have answered this in the trial question sometime last year. This is one of the questions that I spotted last year, I think. The heating element. Okay, but we're going to talk about this anyway. Explain the characteristics of the heating element to boil water faster, easy to handle, and safer. That is what we want. Okay, so let's talk about just the heating element. We're not talking about the kettle. We're not talking about whatever this one we want. Okay, and these are very standard answers. Okay, number one, the material. Okay, the material either is nichrome or tungsten. Okay, and why do we use nichrome or tungsten? Because it is a higher resistance. And remember what I said just now? Resistance produces heat. When you have higher resistance, you will have more heat. Okay, and that's why we want nichrome and tungsten. Okay, so higher resistance, higher heat. Dan sewaktu dengannya you can answer that . Okay, just a side note, the opposite of nichrome and tungsten, which is higher resistance, is constantan and copper. Okay, constantan and copper have low resistance. So it depends on the situation that you want. You want high resistance or low resistance? Remember the material. Nichrome and tungsten, okay, has higher resistance. Constantan and copper has low resistance. Okay, so just a side note okay, if you want to remember. Okay, secondly, the diameter, okay, of the wire has to be small. Okay, also the same thing to produce a higher resistance. Okay, small diameter wire or thin wire also can. You can also say the same thing. Thin wire produces higher resistance. Okay, number three, higher melting point. Okay, the higher melting point will be does not melt easily. And this is very important. Okay, it cannot melt easily, because if it melts easily, then what's the point of the this one, right? Okay, this is the wire there. Okay, the heating element is in the wire. Is the wire. Okay, higher melting point. Okay, then fourth one is what is it? Low rusting rate. Okay, kadar pengaratan yang rendah. And the reason for this is it will not rust easily. Okay, does not rust easily. Okay, and then lastly, use a thermostat. Okay, use a thermostat so that it can control the temperature. Okay, having a thermostat in the electric kettle is what causes the thing to switch off by itself. Otherwise, it's jadi panas, and there's nothing to turn it off. Okay, have you ever wondered how the electric kettle kan dia boleh off sendiri bang? Because there's a thermostat there, and what the thermostat does is it breaks the current, so that at a certain temperature it breaks the current, and then you know that your water is boiled already lah. Okay, so yeah, so the reason why I remember these answers are because it's number one, is one of the trial questions I answered that I discussed last year lah. Because I kind of spotted this question. Don't remember whether it came off for SPM lah. But I definitely remember this because balik-balik kami nampak bah di soalan trial tahun lepas. We saw these questions. I remember these answers. It's like very, very standard lah. Okay, and it's quite easy to remember because it's very logical. If you have an electric kettle at home, just take a look at electric kettle. Okay, very, very normal. Okay, all right. Let's go to the last question. Transformer. Is this the last one? Yeah, it's the last one. Okay. So 24.1. My goodness. 24.1, 24.2 show two transformers, each connected to an identical bulb. It is found that the bulbs light up with different brightness. Okay, so 24.1 is there, 24.2 is there. Look at the brightness, people. Okay, very obvious that 24.2 is brighter. State the function of the transformer. Okay, now function of transformer is to increase or decrease the output voltage. Now, of all the words in here, the word output is the most important. Okay, ini nasihat lah yang diberikan kepada saya oleh guru-guru lain, dan saya banyak dengar ini. I've heard this many times by different people. If there is no the words output voltage, then in terms of the definition, you're wrong. Because transformer, what is important is the output voltage. Okay, yang kita kasih masuk itu tidak penting, bang. What is important is what comes out. Okay, what comes out is actually very important. I'm gonna have such a difficult time editing this video today. Okay, what comes out is actually very important. So the output voltage is the one that is increased or decreased. So the word output voltage must be there. Oh my goodness. Okay, the word output voltage must be there. Okay, to increase or decrease the output voltage is the function of the transformer. If you say to control the output voltage, cannot. Decrease or increase. Increase or decrease, no control. Okay, because control means that you can change it anytime you want to know. But if the number of the coils, kalau dia punya gergelung sudah kena set bahkan, you have no control, you already determine how much is your output voltage. So you're not really controlling in a sense. What you're controlling is the number of coils. Okay. Now compare the brightness of the bulb, number of turns of the primary and the secondary coil. Okay, so this is pretty standard. Everything is 24.1 is, sorry, brightness of the bulb, 24.1 is less bright than 24.2. Primary, 24.1 is bigger than 24.2. And secondary is 24.2 is, sorry, 24.2 is bigger than 24.1. Okay. That one. Okay lah. Relate the ratio. Sorry. Relate the ratio of the number of turns at the secondary coil and the primary coil with the brightness of the bulb. Okay. If the ratio is, okay, so let's take a look. It should be the bigger the ratio, the bigger the brightness. Okay, so this ratio, let's say this is 1, 2, 3, 4, 5, 5 to 2. This is 1, 2, 2 to 5. Sorry, ratio of secondary and primary. Sorry, secondary and primary means this is, okay, 24.1 now. Secondary and primary means secondary di atas, primary di bawah bahkan. So it's 5 to 2. Prime, this one is, sorry, this is 2 to 5. This is 5 to 2. 2 over 5 is 0.4. 5 over 2 is 2.5. So this one, the ratio is bigger. Okay, so the bigger the ratio, the bigger the ratio, the brighter the bigger the brightness lah. And because this ratio is 5 over 2, this ratio is 2 over 5. Secondary to primary. Okay, that's what the question is asking. Relate the ratio, the number of turns at the secondary and primary coil. So secondary divided by primary. So 24.2 is 5 over 2, which is 2.5. 24.1 is 2 over 5, which is 0.4. Small ratio. Okay, sebab dia adalah step down transformer. Okay, so the bigger the ratio, the bigger the brightness. So deduce the relationship between the ratio again and the number of turns at the primary coil with the output of voltage, with the output voltage. Okay, the same thing lah. The bigger the ratio, the bigger the ratio, the bigger the output voltage. Okay, because that's the step up transformer. Okay. Now explain. Sorry. Diagram 24.3 shows the transformer in a microwave oven. Okay, we see the transformer over here. Explain how the transformer in the microwave oven changes 200 to 1500. Okay, so number one, you need to talk about the fact that it is a step-up transformer. Okay, so the words step-up transformer has to be there lah. Okay. Number two, of course, when you talk about the working principle of transformer, this one is, I think we did a video on this. Okay, like how does the transformer this one. So, because we're running out of time, so I'm just going to tell you that make sure that you mention that it is a make sure that you mention that it is a step-up transformer because of the words 200 volts to 1500 volts. Okay, but how the transformer functions. Okay, they say, okay, current flows through the coil and then the cutting of the magnetic flux, okay, because it is an alternating current, yada yada. Okay, so there will be an induced current, yada yada. So all this, I'm just going to say that this is the working principle. Working principle of a transformer. Pergi ulang kaji perkara ini. Okay, working principle of transformer. That will give you the other 3 marks. But I just want to mention that the first mark, or one of the marks in this answer, we have to mention that this is a step-up transformer. Otherwise, you will not get that 1 mark. Okay, last one. Transformer X, transformer Y, residential houses. So, use appropriate physics concepts, explain the type of current supplied by the power station, the characteristics. Okay, so this is number 1, type of current, the characteristics of transformers X and Y, and the characteristics of the transmission cable to increase the efficiency and reduce power loss. Wow, that's like so many things. Okay. Let's talk about transformer X and Y. This is a power station, so transformer X has to be step up. Okay, step up transformer. And why must it be a step up transformer? To increase the output voltage. Okay, this one is quite standard lah. Okay, then transformer Y will obviously be step down transformer. Okay, and it will be to decrease output voltage. Okay, so X is step up, Y is step down to decrease. The type of current will be alternating current. Okay, why must it be alternating current? Okay, sorry, why must it be alternating current? So that the transformer can function. Okay, transformer can only function if it is an alternating current. Because if it is not alternating, if it's a direct current, then there is no cutting of magnetic flux. There's no change in magnetic field. So, so you cannot, step up this one or step down for that matter. Okay, let's talk about the transmission cable. Transmission cable ini ada banyak. We want to increase the efficiency, reduce the power loss. So we reduce the power loss by reducing the resistance lah. Okay, because the problem with this one is big resistance. Big resistance means big power loss. So we want to reduce the power loss. You say that the cable is made of copper. Okay, remember the one I did just now, the heat one? I said if you want high resistance, you use nickel and tungsten. But if you want low resistance, you use copper wire. Okay, so one of these one is to use copper wire to decrease resistance. Because when you decrease the resistance, you will also reduce the power loss. Okay, number 5, small diameter. No, big diameter. Big diameter. Yeah, big diameter. Big diameter. Okay, or thick wire lah. Okay, why thick wire? Also to decrease resistance. So it's exactly the opposite of yang kita hit tadi. And we want thin wire so there's a high resistance. But in copper, we want, in the power cables, we want the wires to be thick so that, of course, it has to transmit a lot of power, a lot of current. But because of that, we need it to be thick wire so that the resistance is decreased. When you decrease the resistance, then it won't lose so much power lah. Dia akan jadi terlalu panas. Okay, let me see if there are any other answers. Yeah. Okay. Okay, decrease resistance by using copper or big diameter and thick wire. All right. Wow. We have finished all these pages of this. Just before you go, sorry, first of all, thank you everyone for even coming in today. Yeah, despite the holidays and everything.